Yeah, hello and welcome to this short teaser video on our paper, a framework for extracting and encoding features from object-centric event data, to be presented at this year's ICSOC in Sevilla. So often real-life processes are structured in an object-centric way, and that means that if an event happens, it is concerned with multiple objects. So for example, if you go to an order handling process, an order could be placed, so it relates to the order, but then also it relates to the items that belong to this order. And then later the different items, multiple items, could be delivered, and that could be captured in one event. But if you look at traditional process mining, it enforces the user to have a sequential structure of events. So it uses then the sequential structure of events as an input. And we have different ways how to translate this object-centric relational event data into sequential event data, and these are called flattening. We can, for example, just pick one case notion and then, for example, order, then put all events of one order into a sequence. We can do the same for item, and we can also look at composite event notions of multiple interrelated objects. But this has all of these flattening methods have certain problems. So for example, we can have deficiency problems where certain events, like here for the order, just disappear and we lose information. We could also have convergence problems where different events are duplicated and we've manipulated information. But we could also have divergence problems where just everything gets flattened into one sequence and we are losing track of to which object does an event belong. And also here we introduce a wrong precedence constraints that pick item needs to happen before produce item. So what we need is an accurate way to capture object-centric event data, and for this we use a graph-based concept of process executions. And based on this graph-based concept, we can then first do an accurate feature extraction. So for example, if you look at the preceding activity in traditional process mining, this can always just be one preceding activity because it's a sequence. But now we can actually capture that there are multiple preceding activities. So for example, pick item and produce item happen before send delivery. And then we do this for many features, given the accurate way how to extract them. And then we provide three ways how to encode features. Two, the tabular and the sequential encoding, are taken from traditional process mining and are heavily used there. And then we introduce a third encoding, that's the graph-based encoding, that actually accurately captures and translates the structure that we see in object-centric event data. We then provide 6 use cases. 3 of them are visualization use cases, 3 are prediction use cases. Here are just the prediction use cases shown, where we use for the tabular encoding a regression, for the sequential encoding an LSTM, for the graph-based encoding a graph neural network. And we see that the graph neural network shows promising results leveraging on the structure, and also through sharp values from explainable AI, we investigate how important different features and structures are. And for example, here we can see that the graph neural network actually uses the different edges in different ways to improve its prediction. So we would be very happy if you come to our presentation at ICSOC 2022, and thank you for listening to this short teaser.